What if a country could turn sugarcane into fuel and reduce its dependence on imported oil? Before ethanol became important, Brazil depended heavily on petroleum and imported oil. Then the 1973 oil crisis changed everything, sending energy prices sharply higher. Brazil needed a domestic energy alternative before the situation became even worse. Brazil already had a powerful resource: enormous sugarcane plantations. Scientists realized that sugarcane could produce something far more valuable than sugar. Through fermentation, sugarcane sugars can be transformed into ethanol fuel. Brazil decided to turn this agricultural resource into part of its national energy strategy. In 1975, Brazil launched Proálcool to expand ethanol and reduce oil dependence. Factories expanded rapidly, creating a completely new fuel industry. But Brazil needed cars that could actually run efficiently on ethanol. Engineers began adapting engines and fuel systems for the new fuel. Soon, ethanol vehicles began appearing across Brazilian roads. Then another oil crisis made Brazil's ethanol strategy even more important. The second oil shock pushed ethanol production to an even larger scale. But the ethanol revolution also faced serious problems with supply, price, and reliability.
Brazil continued improving dedicated ethanol vehicles despite the challenges.
The strategy also transformed Brazil's sugarcane industry. When oil prices fell, ethanol suddenly became less economically attractive. Supply problems damaged consumer confidence and created a difficult period for ethanol. But Brazil did not abandon the technology. Ethanol continued evolving. New automotive technology made ethanol engines more efficient and reliable. Then, engineers created vehicles capable of using different fuel mixtures.
In 2003, successful flex fuel vehicles changed Brazil's ethanol story forever.
Drivers could now choose their fuel according to price and availability. Flex fuel technology spread rapidly across Brazil. Today, it drives the entire nation. The journey from sugarcane field to fuel tank became a sophisticated industrial chain. Inside the mill, sugarcane is processed. Sugarcane is processed to release the sugars needed for ethanol. Fermentation and distillation then transform the sugarcane into usable fuel. Even leftover sugarcane material can help generate energy for the mill. Brazil's climate, farmland, and technology helped create a massive ethanol industry.
Gasoline drives our world, but at a cost. Ethanol can provide climate advantages compared with gasoline when produced efficiently.
Ethanol can provide climate advantages compared with gasoline when produced efficiently. But ethanol still has environmental challenges that cannot simply be ignored. This raises another question. How should farmland balance food, exports, and energy? For Brazil, ethanol also provides another source of domestic energy security.
Brazil's experience became an example for countries exploring alternative fuels. This clean energy transition now drives global markets.
Brazil and the United States became major ethanol producers using very different crops. Sugarcane gives Brazilian ethanol important efficiency advantages.
Today, ethanol is no longer an experiment. It is part of Brazil's transportation system.
Brazil's story shows how a crisis can lead to decades of innovation. What began as a response to expensive oil became a long-term national strategy. The technology kept evolving, from dedicated ethanol engines to flexible fuel systems. The ethanol industry connected millions of people across agriculture, transport, and technology. But Brazil's experience raises a bigger question. Can other countries do the same? Brazil did not discover a magical fuel. It built a system through decades of adaptation. A crop once known mainly for sugar became part of how an entire country powers its vehicles.
Brazil's ethanol revolution was born from a crisis, but survived because the technology kept evolving.
From an oil crisis to a national fuel strategy, Brazil turned sugarcane into one of the world's remarkable energy experiments.